The key for AI really is to understand it is the latest incarnation of AI is machine learning. And everyone's talking about machine learning, deep neural networks. But the idea behind machine learning is that you teach the machine. You show it input examples to a function, show it the output, and it figures out the patterns to link the input and output, and it becomes massive statistical pattern recognition. And here is an example of a deep neural network, which has shown images of digits, the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the input. And then it's told that this digit is number 1, this is number 2. And the neural networks, which sort of mimic the neural structures of the synapses and connections in brain, through many, many, many iterations, algorithm called backpropagation, it figures out the patterns that makes for a digit 0, that makes for a digit 1. And this is what's really new and taken off over the past 8 years, is these deep neural networks learn for itself. In the old way of creating software, you have a computer programmer sitting there writing rules, if then do that, and it would be using data and it would spit out an answer, rules, data, classical programming answers. In the new world of machine learning, it sort of creates the rules itself. You give it the data, pictures, give it the answers, this is a number 1, this is number 2, and it figures out the rules itself. And the key to all of this machine learning on deep neural networks and pattern recognition is data. And this is a subject obviously near and dear to your heart: quality, validated, reliable data. And really, that's the heart of AI today in deep learning machine learning. It's very good at AI, it's very good at predictions and optimizations. And then these predictions, if you look around companies and organizations in the world, what you see is so many activities are actually very amenable to predictions. And so where is it being used? How's it being used in the energy and other industrial sectors? So I'll give you a few examples here of how AI is making predictions and optimizations and how it can create value in the real world. And it's mainly in the energy industrial, but there's a few other sectors I include. One of the great examples that Google points to, or Google's DeepMind, and DeepMind is their research group, is how they use something called reinforcement learning, which is a type of AI algorithm, to lower its data center cooling bills. And you can imagine Google with its thousands and millions upon millions of computers in its data centers, the energy bills are huge. And they were able to reduce it by 40%. And clearly the impact in your industry in reducing energy usage will be worth tens, hundreds of millions. But we also see other benefits of AI in being able to do predictions for predictive and preventative maintenance, which is obviously something that all of you are familiar with in the industrial context. And this shows 3 advantages of machine learning and predictive maintenance, where the first type is unsupervised analysis of vibration data. And using vibration data across the plant, you're able to identify normal behavior and abnormal behavior. There's also, you're able to discover operational modes. And then finally, it's been able to identify black machines by basically seeing what is normal behavior of robotics and what is anomalous behavior. And again, all of this is based on patterns of normal behavior, patterns of abnormal behavior. And the key to being able to build the machine learning to do that is through having the data and reliable data to train the machine learning. Another one is non-invasive tank level monitoring and tracking. So instead of actually having to look and peer down on levels in the tanks, you can use the computer vision to identify where the boundaries are and how it's changing. And these are just simple examples of use cases that are using predictions to best understand computer vision and understand environments. And so there are lots of use cases for AI across energy, chemicals, and pharmaceutical sectors that we touched upon here. There's also a lot of research, for example, this archive paper, going into improving approaches for virtual flow metering and forecasting. So a lot of things that are probably near and dear to your heart here, but how do you use AI in that context? So this probably about sums it up, and this is a leading AI researcher at at IBM, and she says, I like to say you can't have AI without a digital twin. And because the digital twin is the truth, it's the data. And that's really sums up AI. Without data, AI is nothing. And without the data, AI is not going to deliver the benefits that we expect around the society. So a lot of people have suggested that data is the new oil. And you've probably heard that, and you probably joked about it, especially if you're in the oil industry. But really, data is the new oil in an AI-powered world. If AI is an engine that's everywhere, then oil is the power in that engine. And we see that some of the world's most valuable companies are now data-driven companies. The Amazons, the Ubers, the Googles, the Facebooks of the world, their reach and the amount of data that they process is absolutely huge. And with that data, they're able to offer better advertising, better service, better predictability. They have offers that are really quite stunning that is a function of their data. But the analogy goes, well, if data is the new oil to power the algorithmic engines of AI, just like fuel and oil needs careful handling, so data needs careful handling, its sourcing, refinement, and distribution. And I think it's fair. You need to think about, where does your data come from? We need to refine the data to make sure it's quality, it's reconciled, it's validated. You need to store it securely. And you need to transport it and distribute it carefully. You can't just move data around and allow anyone to have access to it. And you need an infrastructure to manage data, data lakes, data pipelines, data management tools. You need strong governance and oversight to this data, and you need to ensure that it doesn't leak and cause damage. We've all seen examples where personal data has been leaked by big companies, and the reputational damage that goes with that. So AI data needs to be handled carefully. So it's very important when we think about AI is, how do we actually build, and how do you build trustworthy AI and data systems behind this? How do we create trust? The heart of making trust is managing the data and then giving transparency and explainability around how the models are working. Are they safe, the models? Are they fair? And is the data that's coming into the models correct and accurate? And these principles are being broadly implemented around the world. And we saw these principles coming into AI, into regulation last week, into starting the process of putting into the law, because the European Commission has launched its draft framework for AI. And it says for high-risk AI use cases, the data sets must be subject to strong governance. It must be subject to review and scrutiny, design, collection, curation, suitability, making sure it's not biased, there's no gaps and shortcomings, validation, reconciliation, all of these things that should be familiar to you. So regulations coming down the line for AI. And what we see in projects is, and people, data scientists using data, they all recognize that a lot of the challenges of putting a good AI system together is there's so many data sources out there, and there's so much inconsistent data that they have to spend a lot of time massaging and wrangling and checking and validating the data. And increasingly, AI is being used based on structured data, sensor data. So this survey by O'Reilly, which is an American tech publisher out of Silicon Valley, showed that 80%, nearly 90% of data being used in machine learning models was structured data like logs, time series, geospatial, things that would be familiar to you. But one of the biggest challenges of building the models is making sure that the predictions that the models make are correct. And if the models aren't kind of working on not reliable, is it because the algorithm isn't good, or is it because the data? So these are the types of questions that are being asked. And it ends up the data scientists are spending about 40% of their time on data preparation. And this is not surprising. I've even heard that, and I've seen in my projects, that we're spending upwards closer to 70 or 80% of our time on data wrangling and data wrangling, data labeling, data cleansing, and like. And as Dominic mentioned earlier, increasingly AI, machine learning, is going to be part of the DVR toolset. AI can see patterns. It can see patterns of data failures or irregular anomalous data. So according to this survey from O'Reilly, almost half of respondents say they use data analysis, machine learning, or AI tools to address data quality issues. Now, I think this sample set is biased. It's extraordinarily technical people in Silicon Valley who are using these tools. I don't think it's representative of the wider industry necessarily. Again, a sampling bias error. But the key point is AI machine learning will be embedded into a lot of the data validation tools and technologies that we will see coming down the road. And so for you, and I'm starting close to wrapping up here, data is absolutely key, and we've got various checklists for AI on how to put it together. It needs plans, it needs people, it needs data, it needs technology, it needs to operationalize, it needs to be risk management. We see 6 factors. But on the data checklist, when you're putting together your activities to build models, you need to make sure you have the right data sources and can access, number one, the data. You need to make sure the data is of a high quality and reliability. And in a lot of cases, the work is about labeling training sets. Huge amount of work going into this data set is good, this data set is bad. It needs to be data risk and governance. And then you'll spend some time building models behind all of this. Data is absolutely key here. So to wrap up, what this all says is we want you in our team. This is very, very relevant to you as data experts. And what we really want is we want you in our AI data team, because as AI grows, and it will grow, more and more and more of your life is going to be involved in getting data ready for the AI models and alike. So for me, it's exciting to talk to you because you represent the future of AI and you represent the future of data.